Hello students, myself is Akhilesh Singh and I am here. I am going to teach you angular momentum and its conservation. So, angular momentum and its conservation. Now, we will find the angular momentum in two parts. Angular momentum, first, of a point object, and second, of a rigid body. So first of all, we will consider angular momentum of a point object. Okay, angular momentum of a point object. Now we will know what is angular momentum. So first of all, angular momentum is moment of linear momentum. What is moment of linear momentum? In previous chapter or previous topic, when you have studied torque, what was the definition of torque? That was the moment of force. Means rotational effect of force. Just like when you open the door, then the force applied will rotate the door about an axis. Getting? In the same way, here angular momentum is the moment of linear momentum. In torque, there was a moment of force, but here the linear quantity is linear momentum, the rotational effect of linear momentum. So it is rotational effect of linear momentum. Okay, the next thing is it is given as L is equal to R cross P. As you all know that moment of any physical quantity is given by cross product. So it is L equal to R cross P. So you can also know that any physical quantity, this is angular momentum and this is vector quantity. So it will have magnitude as well as direction. So what will be the magnitude? R cross P, and direction will be given by n cap. So here R cross P equal to magnitude, and this will be R into P into sine theta, and n cap is direction of angular momentum found by using right hand thumb rule. It will be explained later. Okay, this was theoretical background. Now understand what is the meaning of this formula and how it is applied. This is a Cartesian system y, x. Let there be a point mass m moving with speed v. Let this angle is theta. So here P will be m into v. Linear momentum will be equal to P equal to m into v. Okay. So now this is the position vector r having magnitude r. Its direction is in this direction, r cap, and this is having direction v cap in this direction. So this angle will be having theta value. Okay. Now how will you find angular momentum? So there are two ways. First one is extend this direction of v in back side and drop a perpendicular here. So you will find mod L equal to, here this is the perpendicular distance from the line of action of linear momentum, this value. So if it is r, then this line will having value r sin theta. So this will also having r sin theta value. So you can write here r sin theta into p. So it will be r sin theta into mv. So it will be mvr into sin theta mod L. Okay. In another way, you can, so here you can write it is mod L equal to r perpendicular into p. You can write this perpendicular component of position vector r into linear momentum. Okay, you can write this. Now here in the another way, break linear momentum in two components, one perpendicular to r and one in the direction of r. So here this is p, so this is theta, so this angle is 90 minus theta, so it will be p sin theta and this is p cos theta. Here this p cos theta is along the r, so it will not have any rotational effect. This p cos theta component will not have any rotational effect. What component will rotate it about this point? P sin theta will rotate the point about this origin. So you will write mod L equal to here r into p sin theta, that is r into p perpendicular, and this will be given by r into mv into sin theta. So here L equal to mvr into sin theta. So you can write the magnitude of angular momentum in two ways, either r perpendicular into p or r into p perpendicular. In both the ways you can write the magnitude of angular momentum. Now let us talk to direction of how you will find the direction of angular momentum. Okay. So as you have written the formula r cross p, so it is simply cross product. The direction will be find out cross product, and previously we have written that it will be found by right hand thumb rule. What is right hand thumb rule? Here r cross p. So put the hand or fingers in direction of r, and curl the fingers in direction of p. This is the direction of r and this is the direction of p. So curl the fingers in the direction of p. Thumb will point towards the angular momentum. So here the thumb will, here the direction of angular momentum will be inside the plane, inside the plane containing v or linear momentum and position vector, containing linear momentum and position vector. So direction will be inside the plane containing linear momentum and position vector. Okay, thank you. Now let us have a example, simple example. Listen, let there be a particle m and of mass m, and it is freely falling. So here is origin. So you have to find out angular momentum of particle after time t. So after time t, it will reach here under the effect of gravity. Initial velocity is 0. So after time t, what will be its speed? V is equal to u plus at, and a is equal to g, gravitational acceleration. It is falling with the acceleration of gravity. Okay, so here v equal to 0 plus g into t. So v equal to g into t, and now L equal to mvr. Okay, so L equal to m into g into t, and r is the perpendicular distance from the point of rotation or point about which you have to calculate angular momentum. Let this is b, so it will be b, so it will be the angular momentum. Now second example. Take a second example. Example 2. Let a particle with speed u is projected. So what will be the angular momentum when it reaches at the highest point? What will be the angular momentum when it reaches at highest point? Very simple it is. See, let this speed is u, then component of this speed u cos theta, horizontal direction in x direction, and in y direction it is u sin theta. As you know that in projectile motion, the horizontal velocity component, horizontal velocity will not change, so it will remain constant. Here will be the total speed u cos theta, because vertical component is 0. And here momentum will be m into u into cos theta. Now perpendicular component. So here how you will calculate L equal to, extend this in the back side and draw a perpendicular. This length will be multiplied by linear momentum. What will be this length? This will be the maximum height. So it will be h max into p, and this will be u square sin square theta upon 2g into m into u into cos theta, and this will be your final answer. Angular momentum at the top of the trajectory. you will find this answer. Okay, I hope you got my point and understood very well. Thank you.